Today we are going to talk about lecture 1 and 2 of linear algebra. So here is some linear system. We have three equations here: x plus 2y minus 4z equal 5, then 2x plus y minus 6z equal 8, and the third equation. So we need to convert this equation to something like augmented matrix. Okay, so you just take the coefficient. So here coefficient is 1, here is 2, and here is minus 4, and on the right side we have 5. So you just need to convert, you just need to write down this coefficient here, okay, in the first row. So this is our row 1. So the same way you write down this coefficient here and also this coefficient here. Now let's work on here. So this is our row 1, right? So we have to find the diagonal line. This is the first number. So if I draw a line like this way, so this is our diagonal line, okay? And all the number down this diagonal line, we have to make them as 0, okay? To solve this equation, to solve this linear system, we have to make all the number before this diagonal line as 0, okay? You can see here. So now we have to think what is the way, okay? So if I multiply 2 with the first row, that means 2 into R1. And then if I subtract this 2 into R1 from the second row, that means R2 minus 2 into R1. And we have then we can get something like this. So 2 multiply 1 is 2. So if I substitute this R2 minus R1, so then we can get something like 2 minus 2. So 2 minus 2 will get 0. So then we can just put this value to R2 row 2, okay? We can put this value in row 2. So let me show you. Now I am multiplying 2 with the first row. So 2 multiply 1 is 2, 2 multiply 2 is 4, 2 multiply minus 4 is minus 8, and 2 multiply 5 is 10. Now you substitute this value from row 2. So 2 minus 2, that is 0, okay? Then 1 minus 4, that is minus 3. Then minus 6 minus 8. So minus 6 minus 8. It will be 6 plus 8. Sorry, minus 6 plus 8.
Minus 14.
Yeah, that is 2. No, that is 2. Minus and minus, they will make plus. Okay. So minus 6 plus 8, that is plus 2. That's why it is plus 2. And then 8 minus 10, that is minus 2. Okay. So this way we can get a 0 here. We can get a 0 here. So this 0 is before the diagonal line, right? Guys, can you see? This 0 is below the diagonal line. So this is our diagonal line. And this 0, it is below the diagonal line, right? Okay. So we got our first 0. And this is our, and here is our formula. Now let's work on the second, let's work on the third row. So we have to think, how can we make 0? So if I do the same thing, like if I multiply 2 here, so it will make 4, right? And then if I substitute row 3 from, if I substitute 2 into row 2, okay, from row 3, so it will make what? 4 minus 4, that is 0, right? And then we have to put this value to row number 3. Okay, let me show you. So again, I'm multiplying 2 with row 2. Okay, so 2 multiply 2 is 4, 2 multiply 1 is 2, and 2 multiply minus 6 is minus 12, and 2 multiply 8 is 16. Okay, and if you substitute row 3 minus 2 into row 2, you can get 4 minus 4 is 0, minus 1 minus 2, that is okay, so okay, minus 1 minus 2, that is minus 3. So where is minus 3? Oh, maybe they skipped on line here. Okay, they skipped a line here, so maybe they got some easier formula. So let me think. 2 minus 2 0. Okay, we can make another line. Okay, it's no problem. Like we had on 2 minus 4, then 0 minus 3 2. Okay, here we had 5. 0 minus 2, 12 and 16, 3 minus, this was not 0 minus 2, this was minus 3, sorry, yeah, no, this was 1. Two minus 2 0. Okay, this line minus 3 and 2 and minus 2. Okay, so we are doing another line here. Okay, extra another line, and if I multiply 2 with the row, with the second row, this will be okay here. Zero. Let me rethink. 2 minus 1, 2 minus 2 0. Okay, and now 2 4. How do we got 0? If I multiply 2 here or 4 here, so 4 minus 4, 4 minus 4 is 0. So we can see a upper triangle here. So what is the benefit of making this? For example, this is our diagonal line, right? In the upper triangle here, this is our diagonal line. So we are making 0 here, here, and here, right? That means all the value below that diagonal line, that is 0. So the benefit is we will get some number here. For example, in this matrix, at the last part, we got minus 2 and minus 1. You see here, these three things are 0. So we can just say this one is x, this column is x, this column is y, this column is z. Okay, and this column on the right side, they are on the right side of equation. For example, you see here, like we can write down this way. Firstly, let's think about row 1. So we can write down this whole matrix this way. Like this row 1 here, we have 1. That means this is x. So this is x, this is y, this is z. So x plus 2y minus 4z, okay, is equal to 5. So we can write down this matrix to this way. This is our coefficient 1, 2, minus 4, and 5. And on the second line, we don't have x, right? We have y, z. So we can write down this way: minus 3y plus 2 is equal to minus 2. Okay. And that on the third row, we don't have x and we don't have y, right? We only have z. So we can write down this way: minus 2z. Oh, I skipped z here. This is z, okay. Minus 2z is equal to minus 1. So you can easily find the value of z here, right? From this equation. You can cancel this minus from both sides. So z will be 1 by 2. Okay. Z will be 1 by 2. Just take this 2 from on the right side. You get z equal to 1 by 2. So this way, if I find the value of z, then I can substitute the value. I can substitute the value of z on the second equation, right? Here, I can substitute the value of z here. Then I will get the value of y. So now already we got the value of z and the value of y. So now we can substitute the value of z here and also the value of y here. Okay. Then we will find the value of x. So this way we can solve this linear system. Okay. Guys, do you understand? So our teacher.
Yep.
Yeah. So our Laushi tried to explain this way. Okay. But I was just stuck in this part, like how did they make 0 on this last line? So I just need to see the solution, or I just need to rethink, okay? Because I also need some formula. I have to make some formula like this formula, okay? So maybe I need to see the solution in some other websites. But if I do it right now, then it is like a time-consuming part, right? So we can just see some more example from my notes, okay? So you see here, we have to identify which one is a linear equation and which one is a non-linear equation. So for example, we have some example: x plus 3y equal to 7, and then x1 minus 2 into x2 minus 3x3 minus x4 equal to 0. So if we have 0 on the right side, only 0, okay? If we have only 0 on the right side and everything else on the left side, so this types of equation is called homogeneous equation, okay? Homogeneous equation. And here we have x1 plus 5x2 plus root over 2. So here our coefficient is root over 2, but our variable, it is like its power is 1, right? All the example on linear equation, they are the power of variable is 1. Okay, you see every time here y, here y, the power of y is also 1. The power of x1 is 1, x2 is 1, x3 is 1. So every time the power of our variable is 1. So this type of equation is called linear equation. But down here we have non-linear equation. For example, we have x plus 3y squared. So here the power of y is squared. So this is a non-linear equation, okay? Here we have xy. So this is xy is multiplied here, right? So in linear equation, we cannot write down something like x by y or xy, okay? We cannot write down this way. So if we get something like xy or x by y, so this type of equation will be non-linear equation, okay? And the third example is sin x plus y. So we have a extra sign here, right? That's why this is also a non-linear equation. And on the fourth example, we have root over x1. So we know that root over means something to the power half, right? Root over means something to the power half. So this equation, this is also a non-linear equation, okay? Because the power of variable is not 1. Here the power of variable is 1 by 2. That's why this is a non-linear equation. So let's see how can we solve them. For example, we have x1 plus x2 plus x3 equal to 3. So if I take x1 equal to 1, x2 equal to 2, and x3 is equal to 3. So I will get, oh, sorry. If I take x1 equal to 1, x2 equal to 1, and x3 equal to 1, so I get 1 plus 1 plus 1. So our left side is equal to our right side. So so the solution will be on, okay? Our solution set will be first bracket on, comma, on. Because this value, this is x1, value of x1. This is value of x2. And this is value of x3. So maybe instead of x1, we might have only x. And instead of x2, we might have y. And instead of x3, we might have z, okay? So this way we find the solution of a linear system, okay? And there is another solution, okay? If I let x1 equal to 2, x2 is equal to 1, and x3 equal to 0, so it will make 2 plus 1 plus 0. So 2 plus 1 plus 0 is also 3, right? That's why 2 plus 1 plus 0, 2 comma 1 comma 0, this is also our solution to this linear system. Guys, do you understand? Hello.
Yeah.
Okay. So let's continue here. System of linear equation. So this is the same example above, okay? The solution 1 comma 1 comma 1 satisfies on and 2. Okay, so this is something different. You see here we don't have x3. We don't have x3 here. So if I just let x1 equal to 1, x2 equal to 2, and x3 equal to 3, so we get on plus 1 plus 1. So this makes 3. So here our equation satisfies. And down here we have x1 plus x2. So we know that x1 equal to 1. We already let x1 equal to 1 and x2 equal to 2. X2 equal to 1, also 1. So here on plus 1, it also makes 2, right? So that's why this solution set on, it satisfies the both equation, number 1 and number 2, okay? So a system is said to be inconsistent if the system has no solution. So let me, so this system, it is a consistent, it is consistent, okay? Consistent, because a system is said to be consistent if the system has at least one solution. So we see here this system has solution, right? One solution, maybe more solution. This system has 2 solution, or maybe more. So they are called consistent, okay? Consistent. So they are called consistent. And let me show you an example of inconsistent system. For example, here, okay, x plus y equal to 4 and 3x plus 3y is equal to 6. So if I try to solve this equation, I need to just remove x or y, right? Either x or either y. I need to remove either x, either y. So we have some kind of, we have the equation like this way, right? So if I multiply 3 here, if I multiply 3 with the first equation, so it will make 3x plus 3y is equal to 3 multiply 4, that is 12. And now if I just subtract them, if I just this is our number one equation, this is number 2 equation. So if I substitute the second equation from the first one, so it will be 3x cancel. So this sign will be also get minus. So 3y cancel. And here it will be also minus. So 12 minus 6, that is 12 minus 6, that is 6, right? Or we can do reverse. We can do equation 2 minus 1, okay? 2 minus 1. We can substitute the first equation from the second equation. So if I do that, then it will be, you see here, this is the second equation, and this is the first equation, okay? And I multiplied 3 with first equation. I multiplied 3 with first equation. So if I now substitute, if I now subtract them, so 3x get cancelled, 3y get cancelled, and this sign also get reversed. So 6 minus 12, that is minus 6. So we get 3x cancel, then we get 0. 3y cancel, we get also 0. So 0 plus 0 equal to minus 6. So you see here 0 equal to minus 6, it is not possible, right? That's why it is impossible. So there is no solution. Or you can just think another way. If I just cancel them, so x and y, they two of them get vanished, right? So how can we find the solution? We at least we need x on the left side and everything else on the right side, right? Before you see here, when we try to find some solution, for example, this was x minus y equal to 1 and 2x plus y equal to 6. So we multiply 2 with the first equation. So this will make 2x minus 2y is equal to 2. So now if I subtract them, so 2x get cancelled. So this sign will get reverse. This sign will get minus. So 2y minus 2y, that is 2y minus y, that is minus 3y. And here it will be also minus. So 2, that means 2 minus 6, that is minus 3. Sorry, minus 4. So now we can cancel this minus sign from the both side. So let me erase this minus. And if I keep y on the left side, and if I take this 3 on the right side, so it will be 4 divided by 3. Okay, so we get y equal to 4 by 3. But in this case, our x and y both they get cancelled, right? So we don't find any value. That's why here is no solution. So this type of equation we call it inconsistent. Okay, this type of system, they are called inconsistent. Guys, do you understand?
Yeah, go on.
Okay.
Mm.
So let's continue. Number 3, okay? 4x minus 2y is equal to 1, 16x minus 8y is equal to 4. Now we need to think how can we cancel either x or either y. So if you see, understand now. So firstly, I saw that if I want to cancel x and if I want to cancel y or just 1, we need to multiply 4 with the first equation. So 4 multiply 4 is 16, and this is 8 and 4. So if I subtract them, so it will be minus, it will be plus, and it will be minus, right? So you see 16x, they get cancelled, right? That means 0. Plus 8y, plus 8y minus 8y, they also get cancelled. So we get 0. So 0 plus 0, okay? And 4 minus 4, they also get cancelled. So we get 0 on the right side. So you see here, on the left side we get 0, and on the right side we also get 0. So 0 equal to 0, this is true, right? 0 equal to 0, this is true. So that's why, okay. That's why we have that's why we will have infinite number of solution. Okay, that's why we will have infinite number of solution. And how can we get this line? 4x minus 2y equal to 0. 4x minus 2y equal to 0. Okay, okay, I got it. Maybe 4, 16, 2, and yeah, minus 1 plus 1 by 4y. This linear system has infinite solution. Okay, I got it. 4x minus 2y equal to 1. So maybe there will be 1 here. Okay, 1. Maybe my writing mistake, or I'm not sure. So, okay, let's continue. So we already have seen that this equation has infinite number of solution because the left hand side is equal to the right hand side. Okay. Now we need to convert it something like a parametric form. Okay. So if I take the second equation and if I common 4 here, so it will be 4x minus 2y is equal to 4, right? I just take 4 as a common, or I just divide by 4 here. I just multiply 4 here and I divide 4 here, okay? So, or simply we can just say we take 4 as a common. And on the next line, we can take this 4 on the other side. So it will be 4 divided by 4. 4x minus 2y equal to 4 divided by 4. So 4 divided by 4, if I cancel 4 and 4, so we get 1, right? 4 by 4 is 1. So I can remove this bracket. Now, so this is this equation, okay? 4x minus 2y is equal to 1. So this linear system has infinite solution. So now if I just keep 4x on the left side and everything else on the right side, that means I just take this 2y. I just take this 2y on the right side. So it will become plus. So 4x equal 1 plus 2y. And now I take this 4 on the right side. So this 4 was multiplied. So if I take it right side, it will be divided. So 1 plus 2y divided by 4. Now, according to the division rule, I can just write down this way: 1 by 4 plus 2y by 4, okay? I divide this denominator with 1 and also with 2y. So ultimately we can get 2 and 4. If I cancel 2 and 4, we can get 1 by 4 plus 2y by 2, right? Y by 2. Y by 2. Or just simply half y. 1 by 2y. So this is called a parametric form, okay? Because parametric form is called, you can take any value, you can take any random value of y, and then you will find a value of x, okay? You can take any random value of y, and you will find a value of x. So let me show you a real example here. So how does it look like inside of some kind of real life situation? So see here, we have 3 equations. 2x plus y plus 12 is equal to 1. X plus 2y, sorry, we have 2 equations. X plus 2y plus 9z equal to minus 1. So if I here is the value of z. You can see here. Let me zoom in. So we can increase and decrease the value of z, right? And we can see how this point moves on the upward and downward.